programming concept. So today we covered these topics. Okay. So what are the objectives of this arrays, tree, and structure, fine handling? What are the objectives? Okay. So basically what? Understand the concept of pointers and their role in memory management. Okay. And declare, initialize, and use pointers effectively in C program. Okay. And then declare, define, and access structure members correctly. And understand the concept of fine handling in C. And also understand the concept and working of recursion problem. Okay, these are the objectives. So in dynamic pointers and dynamic memory allocation, first we discuss what is the pointers. Okay, so pointers is basically what? Because pointers is a variable that stores the address of another variable. Okay, that stores the address of another variable. Okay, so the syntax, now we are in the slide number 4. It is visible, students? Hello?
Hello, madam.
Is it visible?
Yes, madam. Yes.
Okay. So,
कौन सा
see,
वाला?
हाँ वो slide number 4, definition of pointer. Okay, so this is the syntax of a pointer. How we declare a pointer? Okay, so first we write the data type, then pointer name. So here is the example: integer a is equal to 10. So that is the integer value. Okay, now we declare this pointer at this way. Okay, and how to declaration of pointers? Okay, so pointer basically a pointer declaration tells the compiler the type of data the pointer will store. Which type of data the pointer will store? Is it integer value or floating value or character value? Okay, so here is the example. Okay, so after declaration, how to initialize a pointer? How to initialize? So basically a pointer must be initialized with the address of a variable before use. Okay, with the address of a variable. So here is the example. First we write the integer data, which type integer x is equal to 5. Okay, then we initialize this pointer. Okay, and then there is pointer arithmetic operations. Okay, pointer arithmetic operations. There are some operations. First, that moves the pointer to next memory location. Okay, and the second one that moves the pointer to previous memory location, and third one is that increment the pointer, and the second is for the decrements the pointer. So this is used in the C programming for pointer. Then dynamic memory allocations. Okay, so basically dynamic memory allocations were that memory allocation during program execution using heap memory. Okay, basically there are some types. First one, functions are used. There's a malloc functions that allocates a single block of memory. Okay, that is single block. Okay, so here is the syntax how to write this malloc function. Okay, so this is the syntax. Okay, first we write the pointer and then which type of data are used. Okay, and this is the example how to write this integer pointer in a that is used in this malloc functions. Okay, after that there is another functions, that is a realloc and free functions. Okay, so in the realloc function, what that resizes previously allocated memory. Okay, that is resizes previously allocated memory. Suppose pointer, that is you have to resize a previous memory location, that you have to write a realloc and pointer and new size. What is the value of new size you have to write here. So this is the example how to reallocate these functions. Okay, after that free functions that releases dynamically allocated memory. Okay, and this is the syntax of these free functions. Then passing arguments to functions. Okay, so basically pointers allow functions to modify actual values. Okay, so modify the actual values. Suppose we have to modify the origin previous value by new value. So we use, there is the example void swap int a comma int b. Okay, so here there is some applications of this pointer and dynamic memory allocations in this pointer dynamic memory. There is some applications. First one is, this is the dynamic array creations. Okay, that basically allows the creation of arrays at runtime based on user input, avoiding fixed size limitations. Okay, then implementation of data structure, that is used in implement linked list, stack, queues, trees, graph effectively. Okay, and then efficient functions communications, that basically enables passing addresses to functions so that original data can be modified directly. And memory optimization, that allocates memory only when required and releases it using free, reducing memory wastage. And then handling large and complex data, that is basically improves the performance of manipulating data through the address instead of copying large data blocks. And then dynamic string and buffer management, that is basically used for handling variable length strings and file buffers during program execution. So basically in C there is a structure. What is a structure and file handling? Okay, so basically a structure is basically a user defined data type. Okay, that allows a grouping of variables of different data types under a single name, and structures are basically useful for representing real world entities such as students name, employees ID and or books. So here is some example how to declare a structure. We declared a structure using struct keyword. Okay, so this is the syntax of this struct keyword. First we struct structure name. Okay, data type, which type of data are used, data type member1 and data type member2. So after declaration, structures variables are defined. For example, here is the example. If we write the struct student, then integer roll number, character name 20, float marks. Okay, so after the declaration, structure variables are defined. Then accessing the structure members. Okay, we accessing the structure members we using dot operator. Okay, how to accessing the structure members? For accessing the structure members, we using the dot operator. So in the last example, the structure student S1. Okay, so you accessing the members with S1 dot, in example you see S1 dot roll of, suppose example 101 we take, and if we print this value, we write here this, you know, as you know that how to print this value using this printf. Okay, after that, array of structure. Array of structure. An array of structure is used when multiple records of the same type are required. Okay, multiple records. Okay, suppose here is the example how to record a multiple records in the same type. Suppose structure student of 50. Basically, that use storing detail of multiple students. That is 50 students. So now file handling. Okay. File handling allows programs to store data permanently or secondary storage. Okay. So basically, files are handled using a file pointer. Okay, file pointer. So here is an example. So opening a file, files are opened during the fopen function, using the fopen function. Okay, so this is the syntax how we write this fopen by fopen function. So here are some file mode. Okay, so here are some file mode that we are used, that is read, write, append. Okay, so how to write a file? Writing a file, we use fprint, fputc function, then fput. These are the functions. Okay, writing a file. And reading a file, that is scanf, fscanf, getc, fgetc. Okay, fgetc. This is the reading a file. Okay, and for closing a file, files must be closed using this fclose function to prevent data loss. So now advanced control structure. Okay, advanced control structure, what that basically help control the flow of execution in a program. They make programs are more flexible, okay, logical and efficient by allowing repetition, decision making and function calls within themselves. Okay, so some applications of these control structures are pattern and matrix processing. Okay, so nested loops are used to generate numbers. Okay, numbers pattern and perform matrix operations such as addition, multiplications. And complex decision making, what that basically nested decision making statements that helps in solving problems involving multiple conditions such as grading system, menu driven programs. Okay, then efficient loop control, break and continue statements allow early termination or skipping loop iterations, improving execution efficiency. And problem decomposition using recursion. So that is basically recursion is used to break complex problem into smaller ones such as factorial, Fibonacci series, okay, Tower of Hanoi problem. And the traversal of data structure recursive functions are widely used for these tree and graph traversal operations. And real world programming applications, that is the advanced control structures are used in games, simulation, searching and sorting algorithms and system level programming. So this is the advanced control structure. So in the advanced control structure, we have nested loop. Okay, nested loop. The nested loop is a what? Nested loop is a loop inside another loop. Okay. The inner loop, what? The inner loop execute completely for each iteration of the outer loop. Okay. So this is the syntax of this nested loop. Okay. Then nested decision making statement. Okay, what is nested decision making statement? Nested decision making means using one conditional statement inside another. Okay, say example, if A greater than B and A greater than C, then A is largest. Then print what? A is largest, or B or C is print B or C is largest value or largest number. Okay. After that, loop control statements. Okay. So loop control statements after the normal execution of loops. There is a break statement and continue statement. Okay. So the break statement terminates the loop immediately. Okay, terminates the loop immediately. So here is the example how to use this break statement. Okay, and in the continue statement skips the current iteration and moves to the next iteration. Okay, so here we use this continue statement. Okay, so we skip the current iteration and move to the, using this continue, move to the next iteration. Then recursion, basically recursion is a process in which a function calls itself to solve a problem. Okay, recursion is a process in which a function calls itself to solve a problem. So a recursive function must have a base condition. A recursive function must have a base condition, and each recursive call should move towards the base condition. Okay, and the problem is divided into smaller sub-problems. Okay, and the problem is divided into smaller sub-problems. So here is the example of this recursion function. After that, what are the advantages or limitations of this recursion? Okay, what are the advantages of recursion? That basically what simplifies complex problem. Okay, and makes code shorter and cleaner and useful in tree or graph traversal. Okay, these are the advantage. And limitation, uses more memory due to function calls. Okay, slower than loops in some cases, and risks of stack overflow of base condition is missing. Okay, so these are the advantage and limitations of these recursion functions. So यहाँ तक जो हुआ आज, suppose like from unit 7 and unit 8 and 9. Okay, जो आज कवर हुआ उसमें से सेल्फ असेसमेंट का जो क्वेश्चंस है, दैट इज द बेसिक क्वेश्चंस, दैट इज हाउ टू पॉइंटर डिक्लेयर एंड इनिशियलाइज्ड, वो ऑलरेडी मैंने स्लाइड में दे दिया, हाउ टू डिक्लेयर एंड इनिशियलाइज एंड what is the dynamic memory allocations, okay, how are structures member are accessed, what is the use of f open, okay. So what is the nested decision making. आप लोग सिर्फ ये दो जो यूनिट कवर हुआ आज, यूनिट 7 एंड यूनिट 9 एंड 8 एंड 9, जो 3 यूनिट्स आज कवर हुआ, आप दोनों एसएलएम ग्रुप को फॉलो करके नेक्स्ट क्लास में मैं इसका एग्जांपल जो है मैं उसे समझा दूंगी, ठीक है।
Okay, madam.
Okay, so it's on next class we cover that unit 10, unit 11 and unit 12, okay. So आप लोग एक बार रिवाइज कर लेना आज जो हुआ, ठीक है।
Okay, madam. Okay, ma'am.
ठीक है।